Welcome back, everybody. Today's Evan Code is going to be a hack job because I want to watch a Christmas movie tonight, and I don't have a lot of time to do it. So let's see how it goes. Okay, so we're going to pick up where we left off. Yesterday, we were able to do both parts of Part 3. It involved Elm Parser. Hopefully, Part 4 will not involve Elm Parser, or if it does, it'll be a slight modification that rewards us for using Elm Parser. But that was Day 3's video. Let's dive in. As usual, I'm going to click. We're going to get the problem, and then we're going to solve it together. Hello. Writing code on the left, and then seeing the output on the right. So that's the big idea. Let's check it out. Let's see what Day 4 is about. All right, Day 4, series search. Series. Looks like the chief's not here. Next, one of the historians pulls out a device and pushes the only button on it. After a brief flash, you recognize the interior of the series monitoring station. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with her word search, which is our puzzle input. She only has to find one word, Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping with other words. It's a little unusual, though, as you don't merely need to find one Xmas, you need to find all of them. There are a few ways Xmas might appear, where irrelevant characters have been replaced with dot. So the actual word search might be like this. So here, 1, 2, 3. So 1, 2, 3, 4. Looks like there's 4 here. Oh, but with this, oh my gosh. With this one, it returns 18 times, which is crazy. So here's the same word search with all of the unimportant words removed. So we need to basically take this puzzle input, and we need to figure out how many ways Xmas can appear. So forward, backwards, vertical, diagonal. Okay, that works. Works for me. I think there's enough examples in here to make sure that that we have what we need. But the goal is we're going to plug this in, and hopefully our program's going to spit out 18, and then we can try it with our puzzle inputs. Let's get into it. All right, so this is our input. We've trimmed it, so we've gotten rid of that white space. We're going to do string lines, and that is going to give us each of these lines one at a time. And we need to basically make it quick to scan for Xmas in certain directions. So we could use a parser for this, but what I think I want to do is basically just, scan left to right and say, does the string start with Xmas? I think that'll be simple enough. So I'm going to avoid using a parser for today's puzzle. But I just need to think about all the directions that this might go in. So this is like one list of strings to go through. So just as a test, we can say list.any has Xmas. So this is going to return true if it finds, any strings that have Xmas. Let's make this a filter so we can just get back to ones. But the idea is we're going to pass in each string one at a time. So we're going to pass in this, and this, and this. And we want our function to return true if we find Xmas in these strings. This will just handle the rows, and then we're going to kind of use this code in all sorts of different directions and variations. And I think we'll have the answer after that. So I'm going to do this so I can scroll a little bit. So has Xmas, it's going to take in a string. We're going to say if string dot length is less than the length of Xmas, which is 4. So I'm just going to say 4. Then we are going to say false. Otherwise, we're going to say string dot starts with Xmas, that string. Then we'll say true. Oops. And keep in mind we have to keep a count, so this isn't going to be the final function. But otherwise, what we're going to do is we're going to say, does the substring, if we drop one character from the left of our string, does that have Xmas in it? So hopefully this is just going to keep all the strings that have Xmas left to right. So I see 1 here, see 1 here, and I see 1 here, and I don't think that any of the other ones, if I like do a search for Xmas here, you'll see that these 3 came back, and these are the 3 that we see on the right. So it looks like this function is doing a good job of filtering and saying keep only the lines with Xmas. What I want to do instead is I want to modify this function to return me a count. So to Xmas count is going to return an integer. So if it's less than 4, we'll do whatever the count is, the initial count, I guess. So let's just set an initial count. Count. So initially, when this program runs, we're going to have 0, and then what we're going to do is we are going to keep calling this function with the count, and then we're going to, in this branch, we're basically going to increment the count before we call it again. So the goal of this is it's going to tell us, how many instances of Xmas we see when we go left to right. So the first string, we got 1, 0, 0, 0 for these, and then we're going to have 1 for those. So if we were only scanning left to right, we would get basically this as our answer, and then we do list.sum, and that would give us 3. And so we'd be like, hey, we found 3 going left to right. But what we need to do next is we're going to need to kind of like transpose this list of strings. And there's some pretty helpful packages in the list extra package. So I'm going to install this, and I'm going to show you in the docs what I'm talking about. There's an Elm community package called list.extra, and I just know about this because I'm kind of familiar with the Elm ecosystem. But you can look up Elm community, and there's a lot of really great packages here if you're looking for something to extend kind of like the core library. This is stuff that's kind of like maybe too fancy to include in the core library, but it's got some cool things in here. So what this one does is it has a function called transpose, which is going to be really helpful for us when we try to get the columns. So transpose is going to basically take our rows and columns, and it's going to flip it so that it's going to start scanning top to bottom instead of left to right. So let me just give you a sense of what that looks like. Import list.extra, import that package. And what I'm going to do here is instead of printing out these strings, I'm going to print out the columns. So instead of the first thing being, let me get rid of this highlighting, this is probably pretty annoying for you. See how lines 9 through 18 here, the first letter it's MMAMXXSSMM. Transpose is going to make that the first element in the list. List.extra. Transpose. I think it needs to work on a list of characters. String to list. String to lines. List.map. String to list. List.map. From list. But now it's going in the vertical. So MMA is the first column. MSM is what you're going to see here. So what we're going to do is we're going to take this input, we're going to turn it into a list of characters. So I'm just going to kind of move this over here in its own variable. I'm going to call this puzzle input. And what puzzle input's going to be is it's going to be like a 2-dimensional list. So it's going to be a list of lists of characters. Puzzle input is going to be this. So when we run this, we're going to get the transpose here. This transpose is going to give us the columns. So what we can do is we can say the rows is just the puzzle input. Oops. Puzzle input. The columns are the transposed puzzle input. We need to find out what the diagonals are. I don't know how to do this yet, so I'm going to do question mark, question mark, question mark. And then what we can do here is we can say for each of these, we want to run that through to Christmas count. So what I'm going to do is I'm going to say rows, cols, diags. and we're going to do list.map. So I guess we can concatenate these into one list of characters. And then what we can do is we can list.map that so that each thing turns back into a string, and then we can run it through xmas count. So what this ends up doing is it says, all right, this is how many times we found xmas in the rows, and then the second half is how many times we found it in the columns. So it looks like the final column has one xmas. So if we look at the ends here, sure enough it does, right? Xmas is written this way. What we don't have is the reversed versions. So we can go a little bit farther and we can say we have our rows, we have our columns, we have our diagonals, but we can also do this for our reversed rows by calling list.reverse on our rows. Yeah, because these are lists of characters. So actually, I think we want a list.map, list reverse, and then reverse calls. It's that, and then reversed diagonals. Sorry, brain freeze thing. So we want to include all these as well. So I'm just going to do this. Reversed rows, reversed cols, and then reversed diags. So this should hopefully have us set up. Once we figure out how diagonals work, this should give us the answer that we want. So when I run this, you're going to see there's a lot more Christmases that we're finding. And so like the final answer will be like list.sum of all this stuff, 8. I think making all these lists and lists and lists might be a performance issue, so we might just have one counter and kind of like work our way left to right through that string. That might be the way we end up doing this, because right now we're kind of making a huge list of strings, we're turning it to a huge list of numbers, but we'll fix that performance problem if we get to it. Okie dokie, what do we have? So 8 is how many we find without diagonals, but I think that diagonals are something we have to think about. So how are we going to do that? We need to basically make these the strings. So if we have, if we know the length of our list, of our puzzle input, so if we know how many columns, we know how many rows, I think what we want to do is basically have like an offset. So let me just kind of describe this string and like the indices that we need to get at. So we need to like get like 0, 0, and then we need to get 1, 1, and then 2, 2. This is like the main diagonal. Like if x is going left to right and y is going down, like top to bottom, we want to grab 0, 0, 1, 1, 2, 2, 3, 3, that kind of thing, all the way up to whatever this is. So in this case, it's 9, 9. So that's the first diagonal, but we want to like basically have offsets too. So we want to say we want to go 1, 0, 2, 1, that kind of thing. So by typing this out, it kind of helps me find like the pattern I'm looking for. We want to do all the way to, what is it, the 9th row. Well, this can't be right. Yeah, 1, 0, yeah, 9, 8 is what it should be, because we end up here, which is the kind of the 8th. It's actually nice that the line numbers do this perfectly for us. So the 0, 1, 2, 3, 4 through 9 actually like works really well. But yeah, we basically want to be in the 8th, the 8th row here, so that makes sense. So we would do this all the way until we just have one list that is just the top right corner, which is 9, 0. So each time this is going to kind of like decrease by one element. That's going to cover the entire like the middle and then the top right of our diagonals, but we also want to go in the other direction. So we need to also account for 0, 1, and then keep doing our, add 1 to each number thing here. So we would do that all the way to 8, 9, I think. And then we would keep going until we get to the bottom left corner, which is 0, 9. So for this puzzle, we have kind of a perfect square. I don't know if it says we'll always get a square. Because if we get a rectangle, it's going to change how far we go. I don't think it's reasonable to think we'll always get a square. Here's an example where we don't. So we're going to need to basically figure out like how far to the right we can go, how far to the left, or how far down we can go, and then kind of keep that in mind as we're scanning through this list. So I think if we start with the puzzle inputs, we just need to implement this toDiags function. I think this is going to be like the hard part of the puzzle. But once we have a list of chars, we basically want to return a list of chars. So list of lists. I'm just going to call this nested list. And this is going to represent, I think, our rows. So what I want to know is I want to get the bounds. So in the case where a nested list has an item, so if it has at least one thing in it, I need to get our boundaries. And if it doesn't, then I'm just going to return an empty list. So this is kind of like edge case handling. So if I have a first row, I'm going to go in here and I'm going to start doing my logic. I'm going to start saying, I'm going to use that first string to figure out how wide we're dealing. So like what's the max in like the X direction? I'm going to use underscores for this. And what that's going to do is it's just going to say get the list length of that first line. I'm going to call this the first line. And I'm going to call these lines instead of nested list. So if we have a first line, we don't really care about what comes after it. That's the max X, and then the max Y is how many lines we have. So that's how far we want to go down. So what we're going to do is we are going to make a list.range. I think there's a clever way to do this where we... No, it's not going to work. I don't want it. I was going to say where we kind of like wrap around the edge, but that's not going to end well because I was thinking like X, M, A, and then we cut over here, but that's going to return. It's not going to end well. Sorry. I'm just thinking out loud here. So what we need to do is we need to get these diagonals going. So what I think I want to start with is kind of the full, like get the max of either. Max of xy is going to be basics.max max x max y, and I think max returns a, oops, let's look this up. This is a core library function. So what I want to do is I want to look at the core library. That's right at the top. I think max returns a, okay, it always returns a value. So if you give it two things, it will return whatever the larger of the two things is. And in the event of a tie, it just returns either of them if they're the same value. So what I want to do is I want to say starting at 0, going to the max length minus 1. That's going to give me my 0 to 9 range. What I'm going to do is I'm going to start with an offset. So this is going to be my, yeah, it's going to be like my initial offset. What I want to do is take that like starting index and then use that in my calculations here. So the goal for this is to have a list of lists, and then we're going to slap them all together at the end. So I can do a map and then a concat, or I can do a concat map. Let me break this into its own function so that it's easier to talk about. So to sublist, it's going to take in an index. And the goal for this function is it's going to take in an int, and then it's going to return a list of characters. And it's going to do that by kind of querying my lines and trying to figure out like what is the value at 0, 0, what about 1, 1. It's going to keep incrementing as much as it can. So inside of here, I'm going to say list.range again. Just like this, we're going to get the kind of the maximum as far as we might be able to go. And then I think we want to keep looping. 0. This is like an offset. I don't know how to, like, at first I was like, oh, just go here. But I kind of need to go here and I need to go down to get the diagonals. These are all like valid starting values, so oops. Like these and these are both valid starting. So this is important that I also include these. So my list.range isn't actually what I want. I want the max x, so this would be 10. I want that minus 1 to handle all of these, plus I want to go to, this is like my going down, so this is really confusing, sorry guys. This is like handling like left to right along the top diagonals. And then this one's going to be like top to bottom along like the left diagonals. I'll call this an edge. Okay, so let me back up a little bit. I'm going to leave this here. It's not quite right. I'm not going to do the max of xy. So this is going to be an integer. This is going to help me think, I hope. So this is like the number of rows. Max x is, I'm going to rename this number of cols. Number of rows. Hopefully this also makes it easier for folks following. There's the number of rows, there's the number of columns. What I want to do is I want to figure out the number of columns when I go left to right. So starting at 0, going to not here, but 1 minus that. So this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I want to subtract 1. That's why that's important. Let me delete this. And then I want to do something similar here. But I don't want to double count this. So instead of starting at 0, I'm going to start at 1 and basically work my way down. That's how I'm thinking about it. So based on the number of rows, it's like, what is my starting spot? So this is going to be like my my x position. And so if I'm going left to right, my x position should be able to tell me what my y position is going to be. So the index that I want to add to the list is going to be like this character. It's always going to be the index. It's going to be the x. And I'm going to add 1 to the last. So I want to basically keep looping. Two diagonal. I'm going to call this two diagonal top edge because it's going to be a little bit different. What I'm going to know is I'm going to know what my starting x is. And then I need to return a list of characters. start x equals that. I'm going to return that for now. This is going to be a to-do. And then we're going to do the exact same thing for the left edge. But this is going to be kind of like the starting y along the side. And then we're going to need to do this here too. So I'm going to to-do. And then we're going to start with this one. I just want to put this in place. I'm going to do a concat map. Concat map just saves me the extra concat at the end. But once I have all those, I think we're good. It's just a matter of figuring out this algorithm. And so the way this is going to work is I'm going to need to be able to very quickly like access values at different indices and like determine if they're out of bounds or not. So the way I'm going to do that is I'm going to take my list of characters and I'm going to make it so that if I give it an int, it will return to me a character. So what I'm going to do is use a dictionary for this. I'm going to say, by the end of this, I want kind of like a coordinate to give me a character. And I'll know if I'm out of bounds if the coordinate I give it returns nothing. And then I'll know that it's time to stop the loop. And I can kind of like, I can call it there. So what I'm going to do is I'm going to say these are my list of chars. I'm just going to call this rows again. Rows. Or sorry, yeah, this is the full puzzle input, right? These are the lines. Is that what I called it before? So list.range. How do I turn list.indexed map, I think is the way to go. That's going to represent my y value. Do a list.indexed map of that to get my x value. And then I'm going to do the value at, this is going to be a line. Sorry, I have a bunch of parentheses here. I'm just like half thinking, half talking. So I'm going to call indexed map. Each index map is going to get the y position with the line. This is going to give me this with the character. So I'm going to say x comma y comma char. And this should give me a lookup for my puzzle. Oh, I need to import dictionary, just like we did in the last video. And we're going to expose the types that I can use it in annotations. Compile that, and then puzzle inputs, it doesn't know what that is. Oops, puzzle input. Great. Okay. Okay, and then this is a list of all this stuff. So I'm going to list.concat this. That's going to flatten it, so it'll just be a list of these things. And then I'll use dict.fromList, which turns this key like value pair into a dictionary. Okay, so that is working. This is always returning empty, which is what our issue is. But I think if I use toDictionary and call this like lookup, and I give it all the lines, this is going to be the dictionary that I want, where I can just give it an integer. I can do dict.get, and then I'll be able to look up a character at a specific spot. So kind of circling back to where we were here, what we want to do is we want to basically keep going until we run out of space in here. So 0, 1, 2, 3. I'm going to also grab this and bring it down here because it's going to be helpful for me to have that local. Oops. This is just the linter being weird. Okay, there we go. Okay. So what I want to do is, if I'm at this start x, I'm going to say, can I get, I think all these are going to have an initial list coming in. List of characters. No, I just want a list of characters. This, by the end of it, should be like M, S, X, M, A. This shouldn't be like a nested list. Sorry, so I did this too many times. But the goal is we're gonna have kind of like a loop. So this is gonna be like the current. I think this map can become a concat map. Because we're not, we don't need to flatten that list of lists. But the goal with this is that I can say, in the case where start X, this is like crazy confusing to talk about as I do it. There's the starting X, and then there's like the, let's simplify here. I think we need to make a helper function. But basically what I want to do is toDiagonal helper. We are going to say the initial X position is start X. So I'm going to use a record for this. The initial Y position is 0. And then I think it's going to add, I just want this. All right, this is getting nicer. So what we're going to do is we are going to just add 1 each time. And then this is going to be the, this is going to be the initial point, and then the initial, like the list that we're accumulating. So toDiagonal helper, it's going to be this function, and I think left edge is going to use it too. So similarly, we're going to have this 0, but this time with start Y, and it's still going to add 1 to each. So I think the actual algorithm is going to be the same. So we're going to have a point, we're going to have the list, and we're going to return the new list. And this is going to be a recursive thing. So int, we're going to have our list of characters that we've collected so far. I'm going to call that current. And then we're going to keep going until we can't find a character at that point, in which case we're just going to return the current list. So this part's actually easy now. I think we've gotten through the crazy stuff. All we have to do is say dict.get. We're going to give it the point that we want. And so initially that's going to be like 0, 0. We're going to give it that point. We're going to look in our lookup, which we put over here. I'm going to bring that down. This is our dictionary. So if we give it a point, it should give us a character. So if we find a character, so like if we're here, it'll say M. And so we'll have that character. What we'll do is we will like add that to our list. So we're going to say current. The order I think doesn't matter because we reverse it, but I'm gonna do it the right way. We're basically gonna add this to the end of our list. So that's our diagonals. And then if we don't find a point, that means we went too far. We basically looped too far, and we want to say just return the current. But the important thing is if we did find something, we want to keep going. So this is our updated list, and we are going to call this again, but this time around we're going to update the point. So we're going to say tuple.mapBoth increment. We're basically just going to do +1 to the point. So mapBoth is going to run a function on both of these ints. So if it's 0, 0, it's going to add 1, it's going to add 1. And so we just need to implement the +1 function, which is a very easy one to implement. You give me a number, I give you the number +1. Int to int. Let me format this. 13. Okay, let's see what we did. So 13, I think this is supposed to be running on the whole thing. Let's see if I did this right. 2 diags. List index map. do reversed x. So 13 is not the answer, right? So we're not quite there. Let's see what our diagonals looks like. I'm not going to concat these. Oops. My keyboard's not, there we go. Sorry, my keyboard was frozen, that was weird. I'm not gonna do all this stuff. What I'm gonna do instead is, I'm just gonna print out the diagonals. I just wanna see what they look like. Oops, looks like I did something wrong. Oh, there we go. Okay, so let's see if these are the diagonals that we expected. So I'm gonna go all the way up to the top here. MSX, MAX, SAMX. I think that's right for the first one. And so this next one, Massa, yeah, M66AM. That seems right. MMX, that looks right. SXM, I'm just like looking on the left. XMA, XSAM, XSAM. And then ASM, SAM. And then empty string? What the hell? It's crazy. Wait, what? It went too far? SAM, empty string. Why did it go too far? Anyway, so I'm going to try this one. MMAS, MMAS, ASAM. That looks right to me. Oh, but I also have to do these diagonals. That's what I'm missing. Okay, so I have the diagonals going this way. Now I need the diagonals going that way. I think this is still easy to do. We just need to add one more set of diagonals. So left to right along top edge. We also need right to left along the top edge. Right to left along top edge. So I'm going to say the direction. So it's going to be, this is fun actually. All right, so we'll do minus, I guess like the direction. This will be top right to bottom left. So we're going to make a little custom type to handle this. This one is going from the top left. The direction of the diagonal will go top left to the bottom right. And then the same will be true for this. And then the same will be true for this. But I think these will change. This will start on the end, right? This will start on the right side and go left. So we want to go top right to the left. And then this one, these weren't even in the right thing. Okay, so that's good. I think the whole program was wrong because I didn't do the. I think I had a copy paste error, but we fixed it miraculously in the final quarter. This is confusing, huh? I'm gonna do one thing. Oh no, this one was to diagonal top edge. Okay, so what I want to do here is I want to say, yeah, I want to go here, 0, and then maybe I'll go from the bottom edge. That'll be easier to talk about. That will add to the x and subtract from the y. Left to right along bottom edge. And then that'll go 0 2 number of columns. All right, this makes it a little easier for me to think about. And then going along the right edge, we'll do the same thing. So this will be from the top to the bottom on the right edge. This one we will start at y equals 0, but we won't go all the way to the bottom corner. This will be number of rows. So it's going to go, and it's basically going to follow, like, it's going to go down, oops, it's going to go down these. And then it's going to go in the other direction. So I think the direction for that is, it's going to be negative x, positive y. So we're going to parameterize this. This is going to be, like update point. And that's going to be a function that tells us how to go from one point to another point, which is going to be important. I'll call this next point. All right, that's something important. And then I'm just going to say that for this diagonal helper, we wanted kind of +1, +1. Same for this one, but that's going to change as we work in the other direction. I think we're going to have 4 variations. Yeah, I don't think whatever. Okay, so that's that. That's this. This is good. That's good. This is along the right, top to bottom. This is left to right along the bottom. Rows, bottom. This needs to say right. I just want to make sure I had all my copy paste correctly done. And then now I think we're ready to implement these 2 functions. So let's steal these guys. Let's just paste them here so we have their names. And then what I'm going to do is I'm going to basically do this, do this, same annotation, but we're going to change kind of where we start. So for the bottom edge, what I want is I want my y value to be, I kind of want this to start at the top edge, but whatever. I want my y value to start at list.length of, sorry, the number of columns -1. Number of rows -1. Starting at 0, working my way up, or whichever way it was. I think it was right to left. That doesn't matter, but this does matter. And so does this one. This one's number of columns. Always start at x all the way on the right. And then what's important is that we go -1 in the x direction for these right diagonals. And we continue to do +1, that's good. But for the bottom, we want to go, we're going top right. So x goes positive. But yeah, I think this is right. There's probably an equivalent way to do this that's more mathematically elegant, but this is the way that my brain can do. So we're going to go with it. And then I think all we need is a -1 function. And then we're good. Hopefully this thing just spits out 18. Well, we need to restore what we had in the bottom. So I think if I delete all this and we did it right, we're going to get 18. And hopefully we don't have any performance issues because it's a little crazy. Int, let me format this. Where am I at? Oh, I think I need an arrow. Yeah, I forgot to put a leading arrow here. Snap everything into place. To next point, takes a point, does it. Oh, and then I want to keep past that along. 18. Okay. Holy hell. Okay, that actually worked. I'm going to save this. I'm going to copy this. I'm going to put it in the notes. We're going to have the all the solutions are included in the description of this video. And I'm going to try it with my puzzle input. I'm going to see if this was bad. Yeah, we'll see. This might spin. I'm going to paste this. I'm going to take all of this and I'm just going to put this over here for now. Oh, 2587. Let's see if that works. Oof, not quite right. 2587. So I definitely did something wrong. That's too bad. Okay. I wonder if one of my minus pluses is just wrong. So right is a negative x. What did I do? Oh, I think I... Shoot, I meant to... I don't think this matters, but I think it matters. That shouldn't give me a different answer, right? It's still 18 for this. Let's save that again. I don't think that mattered, but I did do a screw up there. Oh, 2589, and maybe it didn't matter. Oh, I was gonna say, like, yeah, it's just too high. I was gonna say that's crazy. If it was just that random thing I caught at the end. Okay, let's slow it down some. Gosh, this is crazy. What's crazy to me is that it's possible for me to be out of bounds. Like, I thought number of columns -1 would be cool. Like, I remember when I was debugging this, let me just do this. Go back to just like printing it out. So this is a multi-line comment that's going to allow me to diags. Like, why is there a white? Oh my god, because I put a space in this, that's all. Okay, sorry. Okay, that was not interesting. So this was MSX, MAS, MMX, and they're all decreasing by 1, which is good. Then I want to go the other way. Yeah, there was definitely an easier way to do this because I can just go here and go like this way. Okay, so that's that one. Let's do the exact same thing I just did, but we're gonna go the other way. So 2 diagonal, left to right, going top edge, going bottom left. This is gonna go bottom right. I'm just gonna say going right. Yeah, so this is gonna go this way. This will be the exact same numbers, but we're gonna say diagonal top edge 2. It's gonna be the exact same thing. Start x 0, and then we're going to go. Each number is still gonna go down, but it's gonna go negative. I think this is an easier way to think about it because it's gonna allow me to do the same thing. Oh, the right and the bottom thing was wrong. So I think this might work. Top edge is distinct from the bottom, the right edge, because the right edge I was adding up the same things twice. I'm pretty sure. I'm pretty sure I'm a doofus. I think we're very close though. So I think this can go. Because I was counting the top, I was counting the bottom going to the top right, and I was counting the top right going to the bottom, but it was the same like bottom right quadrant. I think that was what the bug was. And I think with the test puzzle input, it didn't matter because I was basically, I was doubling there was no diagonals, or there were more diagonals here. It canceled out or something because, I lucked out, I think is what happened. Hopefully this still gives me 18. I think this will work. I have restored confidence in myself. Okay, 18. So I changed the code and we still got 18, which gives me hope that this time around it'll work. Because I think, I mean, the diagonals was the only confusing part of the code, so I know the bug's in there somewhere, unless I did something very silly, which does happen. So we're going to try this again. We are going to save this. I'm going to do this. 2576, and earlier it said my guess was too high. I think this was lower. No, it's still wrong. Oh. I have one more thing. I think I'm duplicating this line because I cut off the wrong corner, or I stopped at the wrong corner. If I'm going to do the top left, that's fine going this way. I just need to not start at 0 here. I want to go 1 to 1. Still 18 here, which is good. Saving it again, and I should probably do this. Day 4, part 1. Now that I've named the LE link, it's got to work because I can't fail again. I can't afford to fail again. Sorry that so much of this stuff's like internal in my brain. 67. What did I just do? 2569? I don't remember what I just. Okay, that was it. That was horrible. Okay, let me just draw really quick what I was doing wrong because I think it'll help. Let me see. Hopefully this comes across the video very well. Let me see. I'm gonna make sure that you guys can see this okay. So what I was doing wrong, just drawing on my little pad here, is, so this is like the square, right? So this is the square we have. Imagine I gotta get all the diagonals here. The top and the left was working well because the diagonals I was doing here, this is what I was covering with that first, like 2 diagonal from top or something. And then I was going along the left edge, which was good, and it was covering basically everything on the left edge. So that was good. I was covering all those diagonals correctly. But when it came time to flip it, let me just make, instead of muddying up the whole drawing, I'm just going to make one right next to it with another 6x6. So what I need to do is I basically need to go the other way, right? So instead of starting at this corner, I need to start at this corner. So the first time I did it, I was going right top to bottom. Like that, and that was right. But I was also going bottom the other way. So I was double counting these. The first time around, I was double counting everything, actually except for this one. This one wasn't double counted because of the -2 I had in there, but I wasn't counting these correctly. So what I needed to do was basically have the exact same drawing. The code change that we made was making sure that we didn't have any overlap in the lines. That was a remnant of me doing the -2 for the when I had it flipped. But the result is that we're going this one here is now reversed. So this was what we did with the second time we went through the top. And then what we need to do is make sure that we filled out the bottom. So we were using the same exact write code, which was already doing what we described, which was filling in this bottom half here with like some downward right arrows. And then once you flip that, you get all the diagonals. That was crazy. Okay, let me switch back to this and switch back to the code. That was part 1. Okay, that was part 1. Let's see what happens when we click part 2. Oh my goodness, that was crazy. Okay, irrelevant characters have once again replaced dot. Okay, so part 2. It looks like x dash miss. Irrelevant characters have been replaced with dot. In this example, x dash miss appears 9 times. Wait, it's an Xmas puzzle in which you're supposed to find mass in the shape of an X. Oh God, what? No! No! This is horrible. That's crazy. I don't like that. I don't like that at all. Okay. I think the way we're going to do this is we're going to look for A's, and we're going to see if the A satisfies this and if the A satisfies this. Oh, butts. Okay, that's going to be a pain. All right, so that's crazy. All right, let me just copy this. I think. All right, so let's talk about it. So the example's the same, they say, and it looks like it appears 9 times. Oops, sorry about that. So settings, part 2, save. Okay, so let's ignore all the code down here. What it's saying now, if I understand this correctly, is that this is 1x miss. Also, this is gonna be hard. I think this is an Xmas. I don't think the order matters. There's a few permutations. 2 MAS is the cross. It's horrible. That's horrible. All right, it does kind of shift the way I'm thinking about the problem, which might make it easier. Now we're just scanning. I think we just want to scan for these centers, these A's, and just kind of be like, all right, is there any A where the top left is an M, the bottom right is an S, and like one of these two, basically like the whatever diagonal, I don't know what to call it, like top left diagonal, the bottom right diagonal. Does the top left and the top right diagonals have MAS or SAM? Or do the... Is it just the diagonals? Oh, it's just diagonals. Okay, cool. That's not so bad. All right, this is going to be easier, I think. Let's forget everything we knew, or thought we knew, about all this junk that I wrote down here, and it's finally gone forever. What we're going to do is we are going to call this main, and we are going to go from there. Main equals all this stuff. And what I want to do is I want to rename this main. This is the old main. We're going to clean up that code later, but the idea is debug.toString. I can't spell. And then HTML.text. Oops, that's just floating. You don't need an annotation for that. Doesn't matter. Okay, puzzle input. All this stuff's gonna be upset. Okay, so this is our grid. What we're gonna do is we are going to turn this into a lookup. Oops, I want that function back. Give me that function. Where is it? There it is. This one's important because this one is going to allow us to basically get a letter at each of these things. So we're gonna loop through everything. So this is gonna be our dictionary. We're gonna loop through everything and we're gonna find the Xmas's. So find Xmas's. This is gonna take in its dictionary. And it's gonna return an integer, okay? It's gonna return how many of these Xmas's we have. So this is gonna be our lookup. And what we want to do is we want to like get all the, basically loop through this dictionary. If the character is an A, we are going to query stuff. So coordinates with A is, we're going to do dict dot filter K. This is going to be the point and the char. We're going to filter where the char is an A. I'm just going to return this for now. And I'm going to get rid of this annotation because it's going to be wrong until we fix this. So what this is going to do is it's going to take our lookup and it's going to go through all of these points and it's going to say just keep the ones that have an A. So right now this is going to give me the pair. All I want is the point. So I'm just going to say just give me the points. So notice that all of these are just the A's. This is going to be all the points I have to worry about even checking. And so for each of these, I'm going to say list.map or list.filter is an Xmas. And then if it is an Xmas, so if I go to 0, 2, for example, 0, 2, and I see an Xmas, then we're good. But if not, no bueno. Okay, so all I have to do is make this function. I think it'll be fine. It'll be easy enough. So this is gonna be a point. I'm gonna pass in the lookup because we're gonna use that to like look things up. Go figure. But the idea is, I'll leave this off just a bit longer so that we can basically see which points we have instead of just getting the sums. But this will return true if we found, oops, excuse me, is X, this is going to be our lookup, this is going to be our point, this is like the center point. So I'm just going to say X and Y, and then I'm going to make a bunch of other points. So top left is going to be X minus 1 and Y. And these will come in handy soon. So that's the point to the top left. Okay, top right is going to be, this is minus 1, minus 1. Top right, all the rights are gonna, oops, that should be a plus, not that. And then I'm gonna do a multi-cursor editing thing, so I'm cool. Bottom left is going to just be the same thing. Oops. What have I done? Okay. All right, so that's the top left point, that's the bottom left point. So it's a Christmas if top left is S and top right is, top left and bottom right. So either top left equals S, I'm just gonna write them all out, and bottom right equals M. That's one situation. So that is top left, bottom right, or the other way. So this is true. If is, I'll just say ismos. Ismos takes 2 points, point A and point B. And it says is point A S and point B is M, or vice versa. This is going to allow me to reuse this. Oops. So these are both points. I'll annotate these, I promise. So we're just going to put the top left and the top right and the bottom left. The order here doesn't matter because we did check for both. So top right, bottom left. A equals S. Oh, sorry. This needs to say the lookup is that. So the value for these. So this is why the annotations matter. They would have caught that bug. Int. I'm just going to call this point. I'm so done with all the parentheses that I have to type every 2 seconds. Type alias point equals int. See, I can't type. So this is just a nickname. We don't have to replace it everywhere, but I'm going to do it as many places as I can. It's going to take in 2 points. And it's going to return a Boolean. And then this is going to be point A, point B. A is going to actually be maybe char if we find something. Oops. That's going to be get the value of point A in the lookup. And this will be get the value of point B in the lookup. And so really what we want to do is wrap these in justs. There was a typo there anyway, so it worked out. But you can tell this problem has eroded away in my brain, all that diagonal math. No one should have to think about diagonal algorithms on live camera. It shouldn't have to happen. Society should have prevented this. Okay, so it's claiming that there is an xmiss at x equals 1. 1, 2, 3, 4, 5, 6, 7. It's saying there's an xmiss here. It looks like there is. Looks like Sam and Sam. 2 and 1. Looks like there's an xmiss here. Yep, MAS, MAS. But the result here is spitting back, is that 9? Let's find out. List length 9. It says 9. So that could be it. That could really be it. If I play my cards right, I think that's it. That's the points. I dig it. Okay, sorry, I like this. And I'm just gonna say point here. I think all this crazy diagonal math, all these concatenations can go away. I'm gonna save that. We're gonna copy that. We're gonna have faith that this is gonna work because I can't afford to fail. I can't afford to fail, you know, twice. It's too many times. Bam, compile 2029. That ain't this year, but it's the right answer. We're out of here. All right, I'll catch you guys tomorrow for day 5. Hopefully it won't be an absolute slog. Hopefully I won't be trying to do diagonals and end up drawing a bunch of cubes. Let me know how you felt about me drawing cubes. If that was a waste of your precious time, if that's when you clicked away, you probably didn't make it this far. Or if it was helpful to explain what I was just saying in my head the whole time. I can imagine that would be frustrating because you're not in my brain. So hopefully I did okay. I'm rambling. I'll see you for day 5. Goodbye.